Okay, guys, this is Worm from Worm's Maths Academy. Just thought I'd smash out 2017 Exam 2 Specialist Maths Multiple Choice. Of course, you should aim to do this in about half an hour, so we're going to try and get through it in that time. Okay, first question, the implied domain of 2 cos inverse 1 on x. I just graph it, like that's the easiest thing. So 2 cos inverse 1 divided by x. Sketch. Okay, let's zoom order. Okay, it looks like it's defined from 1 to infinity and -1 to infinity. So I'm thinking C. Okay, the solutions to cos x, 1 on 4 cosec x. Cos x is greater than. I don't think it'll work. What am I doing? I don't think it'll work out on the calculator. So if I said, we can just test it. Cos x is greater than 1 on 4 sine x. Okay, what's that between 0 and 2 pi? Solve. And then if we go, given 0 is less than or equal to, not less than or equal to, 0 is less than x, which is less than 2 pi. Okay, so it doesn't give us a solution, but what we can do is put equals so that we can see where they intersect. Okay, that's not great. That doesn't give us the exact answer. Wonder why that is. Okay, so we're going to have to go back to graphing. So I'll grab this. So the one's going to be cos x. So paste cos x. Okay, zoom, initialize. Now we want it between 0 and 2 pi, and we know that cosec x is the red one, so we want to know when the blue one is greater than the blue one is greater than the red one. So it's going to be from there to there, and it's going to be from here, where that value is, to that value there, and then from this value here to this value here. So there's going to be 3 answers. So we can skip and get rid of 1 and 2. I guess, what do we need to know? Okay, so it looks like pi on 12, 5 pi on 12, they're all the same. Oh, sorry. Scratch. Okay, 17 pi on 2, 12. You could just go analysis G solve intersection and then move. So 0.216, we already know what that is. That's going to be from pi to that value, 3.4. So we can scrap that one. So these two are both still in the mix. So I guess the next thing we need to do is work out our next intersection point, 13 pi on 12 or 17 pi on 12, which is here, 4.456. So then we can go out 13 pi divided by 12 decimal. But if we did 17, okay, so that's our answer. Now we've got to speed it up. The number of distinct roots of this z squared Make sure it's in complex. Edit, clear all. Okay, it was z to the power of 4 minus 1 and z squared minus 3 I z and then minus 2. So let's solve an interactive advance. Solve for z. 1, 2, 3, 4, 5. So there's 5 solutions in the complex plane. Okay, the solutions to z to the n. So if 1 plus I, if you think about 1 across, 1 up, angle is going to be pi on 4, length is going to be root 2. So z to the n is equal to root 2 cis. Bloody hell, I can't spell. And again. Cis pi on 4 plus 2k pi, and as an ln of z, cross out that n, 1 on n, so we're going to get root 2 to the 1 on n, cis, divide them both by n, so pi on 4n plus 2k pi on n. Of course you don't need to write it down, so I think it's going to be this one, because root 2 is the same as 2 to the half, and then when that's to the power of 1 on n, it's got to be 2 to the 1 on 2n, because none of these have square roots. Okay, and now again, a point that lies on the path z minus, okay, so z minus 4, that's going to be 4. The other point is 2, and then up 1, no, down 1, down 1. So we've got to work out the perpendicular bisector of that. That's 2. So the gradient there would be 2 across and 1 up, which is a half. So the perpendicular gradient would be negative 2x plus something. So we can use the midpoint of that. So what is the midpoint? 2 and 4. The midpoint's 3. And that was 1. So this has got to be negative a half. So you get y equals that plus c. Okay, so negative a half equals negative 2 on 3 plus c. So c equals negative a half. Put it on, I'll stuff something up here. 3, negative a half. And you have 2 times 3. So that's 6 plus c. So c equals negative a half plus 6 minus 6. Because that's negative. Okay, so when I add that, I get 11 on 2. So which point's going to go through that? 3, that's going to be negative 6. Oh, we found the point there, idiot. Okay. dy dx equals e to the x arctan y, the value of d squared y dx squared at the point 0, 1. Okay, implicit differentiation, e to the x arctan tan inverse y. E to the x times, where'd it go, tan inverse y, interactive calculation, imp diff. Okay, and then we know given x equals 0, and then given y equals 1, what? Because we've got a y dash, but we know what y dash is. Okay, so let's go back to here. And then if we say, edit, copy, paste, and then we say given y dash is equal to, where'd it go? Copy, paste. Okay, now we've got no y dash, so we can say, come on, move. I think it's frozen. So given x equals 0, given y equals 1, 3 pi on 8. I'm going a bit slow, I think. Okay, where u equal 2 minus x, therefore u dash is negative 1, and x equals 2 minus u. So, what can we say? When x equals 1, u equals 1. When x equals 2, u equals 0. Okay, so 1 to 0. So we can scrap them. Okay, we've got x squared, 2 minus u squared, and then root 2 minus x, so u to the half, du. We're going to put a negative out the front because of that derivative, and we want it between 1 and 0. Is that there yet? Okay. 4 minus 4u 4u to the half minus 4u to the 3 on 2. That's going to be plus u squared, so plus u to the 5 on 2 du. 1, 0, negative. Looks like D to me. Okay, the gradient of f will always be, okay, f dash x is 3x squared minus 2mx. Always be increasing, so let's have a look at, it's always got to be probably easier to do it in the CAS. Okay, so x cubed, if I can write it out properly, minus mx squared minus m times x squared, and then plus 4 d dx oh no, we want the second derivative to be, if it's always increasing, the second derivative is always going to be positive. So x squared, paste, where's greater than or equal to? No, greater than. Oh, it can be equal to as well. Because solve for x. What the hell is that said? Oh, we want yeah, x in terms of m. Why in the hell doesn't it just work it out? Negative 6x, so have I written this out properly? X cubed minus mx squared plus 4, the derivative is greater than 0. I don't get why. So if we solve that, solve for x. What? Okay, f double dash of x is 6x minus 2m is greater than or equal to 0. So 6x is greater than or equal to m. So x is greater than or equal to m on 3. Stupid question, stupid Kaz. Euler's method with a step size of 0.1. Why is 0.8? Okay, I'm just going to do it by hand. So if y0 is 2, y1 is going to be 2 minus, because we're going backwards, so negative 0.1 times f of x, and x in this case is, the hell is x? X is 1. So we're going to get 2 plus 2, 1 plus 1, which is 2 plus 1 plus 1 is, what am I doing? 2 plus 1 plus 1 is 4. So it's going to be subtract 1.96 or 1.6. So y2 is going to be 1.6 minus 0.1, and then we've got to sub in x equals 0.9. 2 times 0.9 squared plus 0.9 plus 1. 2 times 0.9 squared plus 0.9 plus 1. 0.6 minus that. 0.1 times that. 156 on 25, 1.248. There's our answer. Okay. Going a bit slow here, I think. Brain's not working today. Okay. What does it tell us? A function, its derivative f dash and its second derivative f double dasher. Okay, f of a equals 1. Do we know anything about a? Okay, f of a equals 1. F of negative a equals negative 1. Let's just assume a is 1, negative a is negative 1. F of b is negative 1. Do we know anything about a and b? Okay, let's say f of b is negative 1. F of negative b is positive 1. Okay. X plus a squared, x minus b, x plus a squared, f double dash of x equals that. The coordinates of any points of inflection. So the second derivative equals 0. So x equals negative a. No, because it's a repeat. repeated factor, it's not going to be a point of inflection, but that x is equal to b is going to be a point of inflection because it's not repeated. Okay, g of x is negative. We don't really care about that, but it says any points of inflection of mod f of x. So if that is b negative 1, it's got to be reflected, so it's going to be b1. Hard question again. Okay. This will be linearly dependent if, okay, 2m plus n is equal to 2, 3m plus n is equal to 1. What's d? Okay, so if we solve that, we're going to get m is equal to negative 1, and we're going to get n is equal to 4. So, d minus 4n, sorry, md plus minus 4n is equal to negative 2, but we know that n is 4, so that's 16, and we know that m is negative 1, so negative d equals 14. 16, 14, so d is equal to negative 14. So if d is equal to negative 14, they're linearly dependent. Okay, let's try and make up some time. This doesn't look any easier. Okay, the path of the particle moving along cuts out path or circle if, okay, x equals 1 minus root a sine t. So therefore, x minus 1 minus x on root a. Okay, x minus 1 on negative root a squared is equal to sine squared. And then 1, so y minus 1 divided by 1 on b, but it's negative, but that doesn't matter because we square it, equals cos squared t. So x minus 1 on a plus b, y minus 1 squared, equals 1. Okay, it will always be a circle. That's squared. If a and b are equal to 1, oh, that's squared. So ab squared has to equal 1. They both have to be 1. ab squared equals 1. Where is that? No, I forgot to square that. Okay, the vector resolute of a in the direction of b is, okay, I'll do this on a cas. Vector resolute. So we want a dot b hat b hat. Let's just quickly put in a is 3, negative 4, and 12. Oops. Okay, store that in A. And then 2, 2, negative 1. Okay, we want A, comma, unit vector of B, the dot product of those, dot product of A unit vector B. Damn it, that's not B. Okay, and then we want to times that by the unit vector B, 2, 2, negative 1. must put something in. 3, negative 4, 12. 2, 2. Is that alright? Start again. Okay. It's because I defined A twice. Okay. Negative 28 on 9. Oh, you can take out 14 on 9. Yeah. So it's going to be C. This has taken me a really long time. Okay, the system is in equilibrium, and M1 is equal to M1 and M2 is equal to. Okay, so let's work out our forces. So theta, that's mg. So that's going to be mg sine theta. So the tension here is going to equal mg sine theta, and the tension here, that's 2 theta, that's going to be 2 theta, so that's going to be m2, so mg sine m2g sine theta is equal to m1g sine 2 theta. Okay, so m1 on m2, the g's will cancel, so I've got sine theta on 2 sine theta cos theta, because that is 2 sine theta cos theta, so this will be 1 on 2 cos theta, which is 1/2 sec theta. So it is A. Displacement that, the body moves at a constant velocity. 2 seconds later, its displacement is that velocity in meters per second. Okay, velocity is change in displacement. 5 minus j. Sort out x values. Minus 4 plus 4 I j over 2 seconds, so minus 2i plus 2j. Mass put along a horizontal force, 80 Newton, at an angle of 40 degrees. So how much was it? 20 kilos, 40 degrees, 80 friction, 20, and normal force is 20g. So 80 cos 40, that's this, minus 20 is equal to 20a. So 80 cos 40 minus 20 on 20. 80 cos 40 minus 20 divided by 20. 80 cos 40 minus 20 divided by 20, 2.06. The magnitude of the momentum the object is closest to. We know that magnitude of momentum, P, is mv. So we know that initially at rest, u equals 0, v equals, that's what we want to know. A is 2.06. Displacement, don't know, but we know that t equals 5 seconds. So v equals what does it equal? AT, oh, it's just 5 times the acceleration, 2.06, which is 10.3. So that's your velocity, and the mass is 20. So it's going to be 20 times 10.3, which will be 210. Okay, forces of 10 Newton on a body is shown. The resultant force acting on the body will, correct one decimal place, have. Okay, so we just got to add them together. Okay, so it's 60 between that and that, between that and that. Then that has to be 120, which means it's got to be 120. Yeah, that's 8 newtons. So, cosine rule, or we can cheat 8, 10, 120. So, geometry, 8, 8, it's locked, unlock, 8, 8, frickin' clear all, add triangle, 8. Not a very good cheat if it takes you 4 hours to do it. 8, 10, 120. The other side is 15.62. Okay, so I got rid of those two answers. Awesome. And at that, Newton force, so I've got to find this angle in here. So, we can just do it on the CAS as well. Just highlight those two, 33.67. And at an angle edit view, stuff them up. 10, 8, 120. So this angle is 26.33. So it's this one, because I had the forces around the wrong way. Okay, you want to be normally distributed. Mu has a mean of 5 and a variance of 1. V has a mean of 8 and a variance of 1. The random variable double in terms of W is greater than 5 is equivalent to, so we know mu of u is equal to 5, var of u is equal to 1, mu of v is equal to 8, var of v is equal to 1, E of w is 4 times 5 minus 3 times 8, 20 minus, so minus 3, and then var of w is 4 times the variant, no, 16 times, because we've got to square that value, 16 times 1, plus, because when we square negative 3 we get plus 9 times 1, which is 25, so the standard deviation is 25, the variance is 25. Okay, so the probability that W is greater than 5 is equal to the probability that Z is greater than what am I thinking? Did I stuff up U of W? 3 to 24, yep. So that's negative 4 So it's x minus mu. X is 5 minus mu plus 4 on sigma, which is 5 because I've got to square root that. So z is greater than 9 on 5, which is that. Confidence intervals are used to estimate the population mean based on the sample mean. To decrease the width of the confidence interval by 75%, the sample size must be... Okay, so... if it's a quarter, if we want to reduce it by 75%, decrease must be multiplied by a factor of the width of the interval. Sample size must be multiplied by a factor of we're decreasing it by 75%. So that means it's got to be a quarter of what it originally was. Okay, so sigma on root n got to be divided by 4. So the factor of the sample size is going to be sigma on square root of 16n. So therefore the factor is 16. Yeah, decrease the width by 75%. I was thinking you want it to be 75%, but you want to decrease it by 75%. In a one-sided statistical test, 5% it would be concluded that H naught should not be rejected if P, that's wrong, H naught should be rejected if P, that's wrong, should be rejected. That looks right to me, because you reject the null hypothesis if the statistical, if it's a 5% significance level, if it's less than it. Okay, there you go. I think that took way longer than half an hour. That happens sometimes, plus I'm a bit of a veggie today. Hopefully it helped though. Cheers, bye.